Welcome to EDU World Space.
Problem 3.116. In this problem, we have to find location of rivet that should be placed either on line GF or on line GH in such a way that it prevents its all the unnecessary motion. It means that it actually balances all those forces and moments acting on this object. So first what we will try to do, that we will try to convert all these force and moment system into an equivalent system. Let's say that at point G. So at point G, I would like to find all the vertical components in terms of Ry and all the horizontal components uh, in terms of x and moment acting at point G. So for horizontal component and vertical component of the reactions, first we will try to resolve all the forces that are acting on this body. Let's say this 200 Newton force is acting at an angle of 15 degree with horizontal. So we can resolve these forces into its components as its horizontal component will be 200 cos 15 and its vertical component will be 200 sin 15. In a similar way, 120 Newton force can also be resolved in its component as this angle is 70 degrees, so this angle will also be 70 degrees, so this will be 120 cos 70 and this will be 120 sin 70. These forces are already in vertical direction, so we do not need to resolve them in vertical component, and this horizontal component in this problem is given to be 0. So by balancing the forces in x direction, so total reaction of x direction can be written as 200 cos 15. This is acting in right hand side direction, and while this component of 120 cos 30, this is acting in opposite direction, so minus 120 cos 70, and this gives out to be 152.142 Newton. So this is the value of Rx. Now in a similar way we can calculate the value of Ry, and Ry will become minus 200 sin 15 minus 120 sin 70 minus 80, which gives out to be minus 244.53 Newton. This Ry is in negative direction, so it means that it is acting in downward direction. Alright. Now calculating the total moment about the point G. So it will be, since this total distance AE is 520, okay, and AG is 50 mm. In vertical difference between them is 50 mm. So the perpendicular distance between EG will be 520 minus 50, that is 470. So converting them into meter, it will give minus 0.47 multiplied by the horizontal component of the force that is acting there, that is 200 cos 15. Why I am considering here minus? Because this is acting, this moment, the horizontal component of this 200 Newton force will cause a clockwise moment. So clockwise moment here I am considering it to be negative and counterclockwise moment to be positive. Now the vertical component of this force 200 sin 15, it is going to cause an counterclockwise couple, and its perpendicular distance from G is 50 mm. So its moment will be plus 0.05 multiplied by 200 sin 15 plus, not talking about uh, not talking about the moment due to this 120 Newton horizontal component, 120 cos 70, so it will be 120 cos 70, and this will cause a anti-clockwise couple, so I'm using here minus plus sign, and the perpendicular distance between them will be again 0.47. Now because of this vertical component of the 120 sine 70, its perpendicular distance will be, this will be its line of action, so this distance is going to be, this distance will be, since this total distance is given to be 240, this is given 240, this distance is 50, so this distance is 190, so this will be minus 0.19 multiplied by 120 sine 70. All right, now calculating the moment due to this 18 Newton force, this will be in clockwise sense, so it will be give negative minus 8 multiplied by distance between them, that is 640 minus 50, that is 590. So converting them to meter will give 0.59. And now all the moments due to the components of the forces has been calculated. Now there are two moments are also acting in the system, is 42 Newton meter clockwise and 40 Newton again counterclockwise, so both the moments are in counterclockwise, so we can directly add them, 42 plus 40, so all these values can be solved, and this comes out to be here, and this comes out to be minus 55.54 Newton meter. All right, so we have calculated that if we convert this system into an equivalent system, that is at point G, then at point G the moment value is 55.54 in negative direction, so it will be in clockwise sense. All right, so if here I am considering it to be m, so it will be m is equals to, we can write it negative minus 55.54. now we have to calculate, we have to shift these force system that is acting at point G to an arbitrary point, let's say at point P, that is at a distance y from G. This vertical distance is y, so this is our Rx component, this is our Ry component, and here the moment should vanish, means there should not be any moment acting at this point P. So for that purpose, what we should do, that the total moment should be balanced about the point G. So initial moment about point G was minus 50.54. Now after the shifting of the system, the again the moment due to the component Ry will be 0 because it will be passing through the point G. The only component will be due to Rx, and it will cause a clockwise couple, so it will be minus sign Rx multiplied by the vertical distance y. So vertical distance can be calculated from this equation, since Rx is already known. So y comes out to be 0.227 meter. So this is the distance from point B on the line GF. Now for the calculation of the location of the rivet on the line GH, we can again assume the net force system should be shifted at line GH. Let's say this was the vertical component Ry, this was the horizontal component R, and this was our point G, and its distance between these 2 points of application along this line is x. So again the net moment about the point G should be same as before the shifting. So initial moment about the point G was minus 55.54. This should be equals to the total moment due to this force system. Now since Rx component of this resultant force is already passing through G, so moment effect due to the component Rx will be 0. The only effect will be due to Ry. Now Ry is, since this Ry is causing a clockwise couple, so we will use here plus sign Ry multiplied by the distance x. Now Ry is already calculated above. We have this, and this is here minus 244.53. So we can use this value and we can get the value of x, and this x comes out to be 0.364 meter. So for rivet should be applied on the line GH at a distance x is equals to 0.364 from the point G and towards the point H, and in a similarly rivet should be placed on the line GF in the direction of F at a distance 0.227 meter from the point G. So this can be shown on a final diagram like this, that this is the point G, the point F, and this is the point H. So this force can be, if it is acting here, so this distance is x, and if it is acting here, so this distance is y, and its value we have already calculated.